Welcome back to Outward Home Learning. This is computer science and today's topic is decomposition. So to understand a little bit more about decomposition and how it is used, especially in things like games, we're going to go over to Mr. Holton, who's going to explain a bit more about it, and then you've got the first task you're completing is decomposing a game.
Let me give you a key life skill now, and this is something which can be used outside of computer science. It's very useful in computer science, but we can use it in everyday life to just get things done. And it's a skill called decomposition. Let me give you the definition of it first. It's breaking down a large problem into smaller problems so they are solvable. And you can use this in your everyday life. So if you are ever given a problem and it feels a little bit overwhelming, you can use this skill called decomposition to break it down, and then all of a sudden it might not seem so bad. So let's take a typical example of this. Let's do outside of computer science. Let's say you had to revise for your exams. How do you approach that problem? Because there's actually quite a lot to do there. There's actually the revision itself, but that can take a few different formats, but there's also getting yourself organized. So how can we break this down to smaller problems then? First thing that we might want to do is produce a revision timetable. So that's a sensible thing to do. Then you want to maybe get all your materials together, all your books and things like that you'll need. And then maybe you've got the actual revision itself. There's a few more things that we need to do to revise, but we'll do that. And then maybe actually for when I say revision, how can we break that down further? We can do exam questions. We can do mind maps. We can watch YouTube videos like the one that you're watching now. And from then that you might want to produce a set of notes and you might want to produce a set of flashcards. But you see what I'm doing? I'm breaking these down, this big problem down, revising for an exam, into very small solvable problems. So now all of a sudden, to revise for your exam, you know that you need to do this. Maybe this is the first thing that you can do, that you're going to do. Then you're going to get everything together. And then when you're revising, okay, I'm going to do exam questions, I'm going to watch these tutorials, going to do notes, going to do flashcards. You could have other things here like mind maps, but all of a sudden these problems are very solvable. They're very small problems to have to worry about. I have decomposed my problem. And this is the kind of thing that we do every time we put together any sort of program. So let's just pick a sporting game. So let's have a think about, I don't know, something like a football game, maybe like FIFA or something similar. How do you start programming that particular game? There's so much to it, isn't there? So maybe that's, again, we need to use decomposition to start breaking it down. And let's have a think about how we can start to break down that game. Okay, you've got the ball, you need to worry about that. You've got the referee, you need to do something about the rules of the game as well as programming the referee. You've got the players, you've got a crowd to have to worry about as well. You're going to have to program that as well. You've got to get all the different stadiums done as well. And then so all of a sudden we can start breaking these down further. So, okay, so we can do sort of like players. Let's do human controlled first. So the one that you play, how are we going to worry about that? What do we need to do with that one? And then we've got AI controlled. So the ones which are controlled by the computer, how are we going to program that differently? Over here with the ball, I've got the idea that, okay, it needs to have some sort of ball physics, so it needs to be able to be kicked around, but then the game needs to recognize if the ball's in the goal or not as well, see if we've scored a goal. Okay, so let's just break down human control a little bit further. Let's do move player with thumbstick. Okay, so that now is a problem that I can probably start to solve. Move player with thumbstick, and then maybe I can do kick with button. Okay. I can start, these are small problems now. If I apply this level of decomposition to all of these problems, all of a sudden what I'll end up with is a list of very small problems that I can solve and then roll it all up together, and overall I will have this, I'll have my football game. So that the idea of decomposition is just breaking down that large problem and keep breaking it down and keep breaking it down and keep breaking it down until you get to a point where you think you can solve the problem. And it's a key skill, and it's more than just, and you use it more than just programming, so it's definitely one that is worth mastering.
So for your first task, you've been given a screenshot of a computer game. You need to use decomposition to identify the different component parts in that game. So if you open up the decomposition activity, have a good look at it before you get started, and you've got about 10 minutes to complete it. Off you go. And that is time up. So we're now going to go over to Mr. Barnes to explain the answers to you.
Right then, let's have a look at this activity all about decomposition. So here we've got a screenshot of a computer game. I think it's Gran Turismo. And the idea is you are to use decomposition to identify the different component parts of a game. So obviously, if someone was creating a game, it wouldn't be one person that does all of the creation. There'll be a big team of people, and they will be focusing on different bits. So there's a table down here that has the opportunity to list up to 10 different parts. I've done the first one for you. So the first one says recording the position in a race. Okay, so you'll see at the top here we've got the position. Okay, so what else have we got here? So I'm going to say we've got creating the sort of speedometers, okay, in the bottom left there, which says how fast you're going. We've got the time taken, or the lap time. We've got the movement of the car, so like the physics of the car. Okay, we've got the design of the car. That'll probably be programmed by someone different again. We've got, I don't know, let's go the racetrack. The racetrack will be its own entity. We've got the sort of scenery and surroundings. We've got the AI of the other cars, the computer controlled cars. What else have we got? We've got what about the gears and what gear they're in? You see in the bottom right hand side there. So we've got gear shifts, and let's go for maybe which lap and the best time as well. And there's probably others you can come up with as well, but the key point here is like something that is just like a computer game is actually made up of multiple different parts, and these can all be programmed separately to allow people to work on the same project at the same time and then pull back together into a bigger program. It also means you can reuse different elements. So for example, if it was just one sort of program, when you get to a different track you wouldn't be able to use the same position scoring or the timers or whatever else. So it allows them to reuse those bits of code when they make them as well. And there's some of your possible answers for decomposition.
So now it's time for your exam questions. You've got about 5 marks worth of questions, 3 questions in total based on decomposition. We will review the answers afterwards, and you've got around 10 minutes to complete. So that is time up. I think you definitely had time to complete that. If anything, you had a bit too much time. So hopefully you've skipped through. And now it's time to review those answers.
Right, let's have a look at these exam questions then as part of our deliberate practice. These ones are focused around decomposition. So we've got, a teacher researches the length of time students spend completing homework. They want to create a program that asks students how long they spend completing homework each day. Students answer in minutes and hours, for example 2 hours 15 minutes. It will then need to calculate how long they spend completing homework in a week. They want the answer to be displayed in minutes only. So the first question is, describe what's meant by decomposition, 1 mark. Now here's the thing, it's 1 mark, it's clearly a definition question, so actually all the scenario information is irrelevant when answering this question. So I just need to say, what is decomposition? So I'm going to say decomposition is when you break down a problem that is big into smaller, easier to solve pieces. Okay, next then we've got state 2 advantages of using decomposition. So again, it's not really linked to the question yet. So what are 2 advantages? So 2 marks, so it's a state question. So I'm going to say, first of all, decomposition makes it easier to solve problems. Okay, and I'm going to say it also allows for different people to work on different parts of the same problem. Okay, same problem. Because you've got a big problem, you broke up into lots of chunks, and then you can give different chunks to different people and they can all work on it at the same time. Okay then, so now it says, using the algorithm above, identify an input and an output required. So this is where that first point's needed. So it's a state question, or identify question, sorry, so we just need to identify what needs to go in and what needs to come out. So it says here, students answer in minutes and hours. So the input is going to be number of minutes and hours. I'll move this up in a second. And then the output, well, they want the answer to be displayed in minutes only, so I'm just going to put number of minutes. Okay. Right, let's have a look at the answers then. So we've got here, describe what is meant by decomposition. Well, I've said decomposition is when you break down a problem that is big into smaller, easier to solve pieces. So breaking down a problem into smaller component parts, smaller pieces. Perfect. 1 mark. Note the mark scheme says the bit in bold, breaking down a problem, it needs to be that or very similar wording. It's breaking down a problem. Okay, next question then. We've got 2 advantages. So I said decomposition makes it easier to solve problems, so it makes problems easier to solve. That's 1 mark. I said it also allows for different people to work on different parts of the same problem, so people can work on different parts of a much larger problem. Could have also said this reduces the time it takes for software to be created, as things can happen simultaneously. And you could have also said it encourages modular program development, meaning component parts can be used in other programs or other parts of the same program, so you can reuse bits that are made, little sections, because it's all been broken down. And then finally then, before I mark my answers, the input here, we got number of hours and minutes, and then output number of minutes. So number of minutes and hours, same thing, and output number of minutes. So we've got full marks on those questions as well.
And that's what you need to know about decomposition for Computer Science GCSE. Well done for taking part today, and we'll see you next time.